Hi, welcome to today's webinar. I'm Krishan Dimel, and I hit marketing at 99X. And I'm delighted to have Suren Rodrigo, the Chief Product Officer of 99X, with us for this session today. Essential engineering metrics that every team should track. So, guess what? Suren recently completed 15 years at 99X and counts over 20 years in the industry. And during his time, he has taken dozens of products to market and easily, I think he has worked through hundreds of interim releases working in development teams. In addition, for many years, Suren led one of the largest engagements at 99X, which counts almost 40 people. And Suren was leading that for many years. He's also quite hands on and definitely able to go in depth to everything that we will cover today. So, Suren, it's wonderful to have you here with us and to have you share your insights. So, just to give you an outline of the agenda, we'll initially start with maybe about 30, 35 minutes where we will have a discussion around some of these topics. Then we'll move to a segment on a Q&A, and you can definitely put your questions on the chat. And following that, there's something exciting that's lined up right at the end. So stay tuned for that. So let's dive in. Whatever systems that you set out to build, whether it's a application in an enterprise or a software product or a platform, two questions always come to mind. And these two questions aren't really new. I think they're as old as the industry itself, right? But these two questions are still relevant as when they were first asked. So the first is, are we building the right product? The second, are we building the product right? Are we building the right product? Are we building the product right? These are very simple questions on the surface, but as you go into a bit more detail, you will see that it's leading us onto two different tracks. One looks at why the product is being built or what is being built as well together, and the other, how it's being built. So we are going to start off with this first question. Are we building the right product? And Suren, I'd like some of your thoughts and views. What does this mean? What does right mean? And let's start off from there. Suren, over to you.
Yes, so welcome everyone, and thank you, Krishan, for the introduction. Yeah, so as you said, it's a very popular question and a very relevant one, regardless of how old the question is. So the interesting thing is when we talk about the right product, so most of us refer to the correctness of the features. So we look at whether this product has the right set of features. But if you really look at it, what decides whether a feature set for a given product is right or wrong? So it's actually the market forces that kind of decides whether a software product, has the right set of features in that given context, right? So if you can remember, if you think back to a product that you have been using for years, maybe you can think of it, if you take simply a word processor, the set of features that was right 10 years ago have now evolved, right? New features have come in because those were not correct right now. And the features that we are thinking correct right now will of course not be relevant in 10 years with the new innovations that are coming in, especially in the field of AI. So rather than focusing on the rightness or the correctness of the features when we say we are building the right product, um, I think it's very important to build products with the right capabilities, right? Why I say that is, if you build a product with the right capabilities, a product with the ability to kind of continuously be validated from the market, can scale properly. You can extend it to different new requirements that is coming in, right? It has the right set of security built in, and the privacy capability to enhance the privacy continuously. So if you build a product with those right capabilities, you allow this product to evolve correctly to meet the demands of the future, right? So then you can always keep this product relevant for the life cycle of the business. So I think that is what we should kind of think when we say we have the right product in the market. The good news in this is that we have known how to build right products now for so long, right? So agile methodologies have evolved so much from its inception, and I think they have kind of brought us very good management processes, management methodologies to build these type of capable products that have the right scalability, right adaptability, and all of that. And even engineering practices have evolved so much with these with a lot of new innovations. So for example, 10 years back, shift left on security or shift left on quality was not a big thing. But I think now we are talking about those type of engineering practices, which we need to kind of implement, built into the product, security built into the product, right? So that type of engineering discussions are now there. So when you're architecturing a product, you kind of focus on all of that now. So it's actually the good news, as I was saying, that we now have good management processes and also engineering methodologies to build these type of capable products. However, if you look at the market, the kind of the bad news in this is that we still have a lot of failures, right? So we see a lot of software projects do not achieve their goals. So they sort of fall short in achieving the 100% objectives of building this product. One reason I see why this is happening is that we fail to kind of execute this product development process correctly, right? So we are challenged in our execution. And if we really look at why we kind of are challenged when we execute our software development projects, one of the key reasons that come out is that we are not measuring the right things. So our measurement methodologies that we use to measure the development process is not good enough, right? So we all know that if we don't measure something, we cannot successfully manage it, because measurements tells us whether we are moving in the right direction or we are deviating from our original path, right? So this is kind of the key reason why most of the time I see today in the industry that projects are failing. I think that's kind of focus on today's webinar also, to look at the measurements closely. I hope I answered your question also, Krishan, during my discussion.
Yes, yes, you certainly did. What's interesting is when you take some of the SaaS products or the applications that to be built, which are quite complex. In that case, we have in some cases hundreds or thousands, or for some select applications, even millions of users, right? So when we are in that level of complexity, what are some of the measurements that we need to think about, and how do we try to really get a handle on some of those measurements? What are your thoughts on that, Suren?
Yeah, that's a great question. Actually, when thinking about measurements, so one of the key things we have to look at. I see there are two parts to this problem of the challenges when we try to measure a software development project. Uh, Basically, one problem we have is that we don't have enough metrics in place to measure things, right? The other problem is that uh, we have set of metrics, but those are not the correct metrics. Right. So that is, I feel, a little bit more complex scenario, because in the first scenario where you know that you don't have the right set of metrics to measure the development process, then you can actually take corrective actions. You know that you don't have this in place, right? So you understand the situation. However, when you are measuring certain things, you already have certain metrics in place, but those metrics are not the correct metrics that you need to apply in the software development process. So that is a little bit more dangerous, because this gives you the false sense of security. This gives you a notion that you are measuring things, that you are going in the right direction, but it's actually not giving you the right measurement to measure the process correctly. So a good example, I think people who are old enough will remember about what happened to Nokia. So when agile movement was kind of kicking in back in 2007, 2008, Nokia had something called the Nokia test. So they were the de facto people who implemented agile methodologies. So they were measuring everything in an agile based way. However, they kind of failed to materialize in most of these projects. They kind of failed to materialize a market winning product out of these things. The main reason being, I mean, I won't go into a lot of details. This is all in record. You can Google and see what happened to Nokia. One of the main reasons why they failed was they were measuring the wrong thing. They were measuring output. They were not measuring outcomes, right? So this is a very important thing that we need to distinguish, right? So if you are just measuring your velocity blindly, right, in a typical Scrum project, if you're just measuring the number of story points that you're burning, so that's kind of an output. You're not measuring the outcome. What was the business value impact that was created out of the things that you have produced, out of the work that you have completed, right? So this thing is very important to understand when we kind of talk about measurements. This problem is it's very important to understand the problem clearly. What in the realm of measuring things. And coming back to your question, Krishan, to understand what metrics that we need to measure in a typical software project, I can actually share something and show you. Um, so I hope you can see my screen.
Yes, all good.
All right. So this is a typical, basically a typical software development lifecycle phases that we go through. So we have features that are in the to-do column, then we kind of move it to in development, testing, review, and then we say we are done with the development, and then another process or another set of team will deploy those features into the production environment. So this is a very standard, typical product life cycle that we see. So if you take a product life cycle like this, there are two main categories that you need to measure in this. So the first category is kind of the product engineering category. So you need to measure how well do you actually produce, or how efficiently or how productively do you kind of produce the software, how do you develop the software. So that is kind of what is taken care of by these product engineering matrices. So after you have developed it, it's in your version control system. The features are committed to your version control system. The second set kind of focuses on how efficiently do you deploy this to your production environment. I think the second part is really popular these days, because this is covered by the very popular DORA metrics. So DORA is the DevOps Research and Assessment metric, which is a very popular metric that is used in DevOps and product development, product engineering, to measure the efficiency of delivery. How efficiently can you deliver software to the production environments? So it has certain matrices that talks about uh, these efficiencies, like development frequency. Sorry, deployment frequency talks about how frequently do you deploy to the production environment. So Some organizations deploy more than 50 times per day. Some does 100 times, some does 20. So depending on your need. So this kind of tells us that. Lead time for change tells us how long does it take for a given commit to be deployed to the production environment. Change failure rate talks about how much of failures occurred out of the number of features that you have deployed into production, right? Mean time to restore is basically the time that you take, average time that you take to restore if a production bug comes. So these four matrices, this is scientifically also proven that if you measure these four matrices in a environment where you have a production system, you can actually maintain your production environment in the most efficient and productive manner. But what is not discussed so often is how do you actually measure your product engineering aspect? How do you measure your product engineering flow? So this is something that is little bit kind of not discussed that often. And for that, I see there are different dimensions that you can measure, right? So one dimension is the speed dimension. The other dimension is the efficiency dimension. There can be some other dimensions as well, which I will just touch upon a little later. But if you take lead dimension, under lead dimension, there are several matrices that we can actually use in order to measure the speed of the development team. How fast do you move features from your to-do column to your development done column, right? So these matrices are kind of targeted to measure that. So if you take lead time is kind of talks about the how long does it take for a feature to go from its inception, for in this case it's the to do column, to its done state, right? Coding time, something like coding time is very easy to understand. It's kind of tells us how long does it take for us to code the feature. And after coding a feature, usually you kind of want somebody to review it. So the review time kind of tells us how long does it take for somebody to review a feature. Review pickup time is actually interesting because it tells us once a feature is coded and when you kind of assign somebody to review it, how long does it take for somebody to actually come and pick it up for reviewing, right? So that is kind of the review pickup time. So these are some of the key matrices that we can measure in the from the product engineering aspect. And the other part is the efficiency. How efficiently do we kind of manage or push features into our code base? So things like PR throughput talks about how many pull requests do we create for a week or a month. Because a pull request, when you create a pull request, you're actually committing or you're pushing code into your code base, and you're making sure that it's merged with the main code base, right? And the size of the pull request is also an important metric. It tells us whether you have, if you have large PR sizes or pull request sizes, that will kind of forces the developers to take longer to review it, right? So it will result in longer review time if you have high PR sizes, large PR sizes, right? So commit frequency. So it measures how often you commit your changes to the version control system, right? So if you have a low commit frequency, that means your team is keeping code in their local machines and they are not committing it enough to the version control system. So likewise, there are a lot of metrics that we can use to measure the speed and efficiency dimensions. And along with that, there are other dimensions we can also measure. Quality, security, team satisfaction, all these things are relevant in kind of ensuring that we kind of do the product engineering aspect in the most efficient and productive manner. So these are some of the metrics that we can use to measure. The next obvious question is, how do we actually measure these things? So that's actually something that is very interesting. Because we had the same question when we kind of got into this measuring thing. We wanted to measure how efficiently and how quickly our development teams are doing the product engineering activities in our projects. Then when we get into it, one of the key problems we had is how do you actually measure all these metrics, right? Because it sounds a little complicated, right? So then we realized that there are platforms that actually can do this. Those platforms are what we call software engineering intelligence platforms, right? We call them SEI platforms, right? So using SEI platforms, we can actually make sure that we gather the data from different sources, because usually the data that is required to do these analysis are scattered around different systems. So for example, you might have a task management system that is in Jira, a version control system that is in either GitLab or Git or Bitbucket, right? And you might have a quality management system, some other quality management system, right? So you use different tools for different purposes in a typical product management engagement. So the SCI tool or the software engineering intelligence platform should be able to read this data from these different sources, and it needs to process them in a secure manner. So it does the transformation. It transforms these data into different insights, right? So it needs to transform this data into meaningful insights so that we can understand how what are the values for these matrices in our product, right? So this is how actually we can implement it. And if you look at a tool like Flowwiser, which is 99x own software engineering intelligence platform, this exactly does that, right? So this kind of connects to different version control systems and task management systems, and it gathers data and it kind of produces these information or these insights for our development teams so that they can actually look at this. Every iteration they can look at this and recognize what are the areas that they want to improve. So I won't go into detail. I think we will discuss a case study towards a little bit towards the end of this discussion. But as you can see, all the information that was presented earlier, the shelf time, pickup time, coding time, all this information is available for the development, and these dimensions, speed and efficiency dimensions, are also available. So this is Flowwise is just one SCI platform. Of course, there are other platforms that are available there. So this is how I think, Krishan, that you can identify what are the metrics that you can use, the right metrics that you can use in your product development engagement, and then how you can utilize a SCI platform like Flowwise to integrate it into your product development process.
Great. Thanks, Suren. Yeah, that's a lot of ground that we covered there. So when I look at this and what you said right at the start about outputs and outcomes, and really it's the outcomes that finally matter, right? So how practically does the so for example, to solve a problem, or whether it's relating to the team's output or throughput, how do you use some of these metrics in real life? Maybe just take us through an example, one or two, if you can.
Yes, of course, Krishan. One other thing I just want to mention before I get into the examples is that so one thing we need to be a little bit careful when adapting a SCI platform is that some SCI platforms are there. They only connect or they only create insights from one tool or one source. For example, if you are calculating your lead time, right? And if you are only extracting data from Jira, your task management system, right? Then it will only work it will only work based on how you manage your tasks, right? So when you move your story from in progress to done, it will use that information only, right? So it's kind of like a again going back to this output versus outcome based thing. So it only depends on your action of moving this task from in progress to done, right? However, actually what should happen is it should kind of verify or validate whether you have actually done something related to that task, whether you have actually committed code, or whether you have actually created a pull request for that particular feature, right? Because otherwise you can simply go and move it and there's nothing added related to that task to the code base. Because if you are not adding anything to the code base, then you are essentially not adding any value to your software product also. So whatever the value change or value increment that you want to see in your product, it has to be reflected in the code base, right? So this is one of the key things we were looking at when we built Flowwiser also, Krishan, because we wanted to make sure that it doesn't take data from only one system, right? So it needs to connect to both version control and task management system, and it looks at the pull request as the base, right? It looks at the pull request, number of pull requests created for a given period, and then it backtracks, okay, for this pull request, there is this number of commits. And when you are committing, we kind of associate a task number with that commit, and we use that task number to tie that commit into with the task in the version your task management system. So this way we ensure that whatever the task information that you see in Flowwiser is not just randomly or just blindly taken from the task management system, but there's an associated code added to the code base with that, right? So this is kind of how we make sure we are always basing our metrics based on outcomes, not just kind of output, right? And looking at case studies, there are two ways I think tools like any SCI platform can be useful in our day-to-day development. So one thing would be one way of using a SCI platform would be to solve specific problems, right? So let me give you an example for that. So a few years back, I think one of our customers had a issue where he had a competitor who was actually deploying much faster than his team to the production environment. So the competitor's deployment frequency was really high. And he could not, so his customers were kind of moving away from his product and adapting his competitor's product, because the competitor's product always had new features coming out more frequently than his product, right? So this was a big problem for him because he was losing market share. And he kind of went to his team and said, why don't we kind of improve? Like, can't we deploy to the production more frequently? Or can we match my competitors' deployment frequency? But the development team said no, because they're working as fast as they can. So when the customer came to us, we obviously looked into the obvious stuff. We looked at the team. The team was really good. They had a lot of experience with the customer. They had good competency, and all of that were there. They knew the domain and everything. So there was nothing wrong with the team's competency or their capability. The process was also good because they were using agile Scrum methodology, and it has helped them to kind of deploy good valuable features to the market before as well. But what was interesting is that when we looked at the lead time, so we decided to kind of measure. So we used our ACI platform, and we started measuring different metrics, like all these metrics that you see here. So when we looked at the lead time, something interesting came out, right? So if you look at the lead time of this team, you can see their coding time is 10 days, and their review time, or the total review time, the time they take for the entire review process, is also 9 days. So that this was a little bit fishy, because they are almost spending the same amount of time that they used to coding for reviewing as well. So 10 days for coding and 9 days for reviewing, right? And then when we looked closely, we saw that they had a review pickup time of 4 days, right? So what this meant was somebody goes and codes something, creates a pull request, and it just sits there for 4 days for somebody to come and pick it up for reviewing, right? So if we can reduce these 4 days by to, let's say, one day, we are saving 3 days without any issue. So I create a pull request today, so someone else will pick it up the next day. Then instead of waiting for 4 days, then I can save 3 days from the lead time without issue. So when we asked why you can't do that, why don't you do that? They said we like to do that, but it takes us 5 days to review something. That's almost half of the coding time, right? So the only time architect or somebody who can review a pull request will come and start reviewing it is after they complete their own tasks, or after they kind of complete their own commitment, only they will come and pick another task for reviewing, right? So then we looked at why does it take 5 days for reviewing, right? This kind of forced us to look at the pull request size, because as I told you earlier, if the pull request size is bigger, obviously it will take a longer time for the team to review it, right? Reviewer to review it. And looking at the pull request size, it's 750 lines on average. That's a huge number of lines that the team has to, a person has to go through. 750 lines of code, either lines added, deleted, or modified, right? So it's a large number which they have to go through. So then we realized, when we looked at this, after we realizing this, we went back to the customer and had a discussion with him. And there it was evident that this team has enjoyed releasing large features to the market from the beginning, right? So they celebrated releasing big features with a big bang and all of that. Whereas the competitor was adapting a methodology where he has very small features, which he frequently released to the market. Obviously, the customers love the competitor's method. And when we looked at this, it was evident. And we told him, so he agreed to kind of change the methodology. But that's not the interesting thing we found out by analyzing the PR size metric. Look at these numbers, right? The added, deleted, and modified line numbers. So we knew this project was it was a startup and it was in its growth phase. So for a project that is in the growth phase, what we would expect is for people who are developing that product to spend more time adding lines of code rather than modifying lines of code, right? Because in a startup phase project, what you would expect is for new features to come out as frequently as possible. So the only way you can add something new is by adding something new lines of code to the code base, right? So if you look at these averages, uh, so they have used, by the way, we monitored this data for 6 months, right? This is 6 months data that we analyzed. So during the 6 months we analyzed this data, it was 183 pull requests were created to add on average 220 lines. In contrast, this team has used 580 pull requests to on average modify 445 lines. That means during the last 6 months, the high focus has been on modifying lines rather than adding lines. So there can be two reasons for this. Either there are bugs in the system that is forcing the team to modify or fix these bugs. Fixing means you are modifying the code lines. Or in order to add a new feature, they actually have to edit or modify the existing code, which is again indicating a design flow, right? So because of that, their focus has been more into modifying lines rather than adding lines. So when we bring this to the surface, the customer was really happy, and they actually found several issues in their engineering practices and also in their architecture, which have contributed to this, right? So they fixed it, right? So this is one case study that I kind of like to elaborate, because this shows you how you can use a SCI tool like Flowwiser to fix a specific problem. Our customer had a specific problem. He didn't have good enough deployment frequency from his team. But when we investigated using a tool like Flowwiser or any SCI tool, we kind of not only figured out the root cause, which was the large PR size, but we were able to analyze it further and detect kind of a issue in the pattern that they work, right? By figuring out that they were focusing more on modifying lines rather than adding lines, right? So this is one way that you can utilize Flowwiser, or rather any SCI platform tool like Flowwiser. The other thing is that you can utilize these tools. I can show you from our sample data set, is by kind of setting small goals, right? So if you look at these patterns, so let me show you. So here, if you look at this is the PR throughput for this particular, this is a sample project, sample test team project that we have. So you can see the PR throughput has undergone kind of a dip here. This is probably because of the holidays. And then it has gone up to 28 pull requests per week. And then it has steadily gone down. So you can actually analyze these and see, and you have we have given you some insights here. Compared to last week, what is the PR throughput has gone down by 30, likewise. So you can analyze this data to continuously have a discussion with your team. So every iteration, you can use this data to kind of build a conversation with your team to figure out why this happened, right? So same goes with speed. If you look at it, so if I just remove some of these items, then this becomes clearer. So you can see we have the coding time analysis. So coding time has gone like this. So we can have a discussion with the team why this pattern is why do we see this pattern in our product, right? Because the coding time, what we like to see as time passes to go down gradually, right? So we want coding time to be less and less. That means team is more efficient in their coding, or they are coding in smaller chunks, right? So we want the coding time to be smaller and smaller. So so from Jan to March, I think it's correctly following the pattern, but we see some hype here. So this is something area that which they can kind of investigate. Another thing they can do when they use tools like SCI tools is to set certain goals, right? For example, let me show you a goal that I have set for the coding time for this team. So when I kind of look at this goal, so I have set the goal should be 6 days. So I'm saying we should commit to a goal of coding time of 6 days, right? In our lead time, we have to commit to a goal of coding time of 6 days. So then we can monitor how we perform against that goal over a period, right? And we can take corrective actions, right? Same way we can kind of set certain goals. Commit frequency, I think every team would like to see their commit frequencies increased over a period, right? We want our developers to commit more frequently. So we can say, why don't we commit at least 50 times per month, something like that, right? So by committing to a goal like this, it's very easy to kind of continuously monitor, and you can see how we have performed against that goal, right? So this is the second way that you can use tools like Flowwiser or any SCI platform to kind of set certain goals, and also to continuously look at the behavior, the patterns that you see, and have a continuous discussion with your team of how you can improve. Because then you can kind of build that discussion in a very quantifiable way with your team, rather than saying, why don't you, your commit frequency is not enough. We can set a team goal, and this is a team goal. This is not an individual goal, right? So the whole team is committed to do this. So even one person doesn't do it, it will have an impact on the average, right? So these are the ways I feel, Krishant, that we can really utilize these tools in a day-to-day basis. I hope it's clear.
Yes, yes. Thanks for what you've shared. And I that issue that you described, I mean, what you have on screen right now, how to, if you had to figure that out through other means, it'll take you so many cycles to get to really, to narrow down and say the size of the pull request is the issue, right?
Yeah,
Um, so
exactly.
just to, yeah, so just to remind everyone, you can share your questions on the chat. So please do. So, Suren, what are some of the barriers or challenges to adoption? I think we see that practically also when we run this. But what do you see there?
Yeah, it's actually a really important question because we face the same challenges when we try to implement these tools in our day-to-day development. So one challenge is that the data is kind of scattered around, right? And they use different, most of the time, different teams use different tools, right? So your whatever the SCI platform that you adapt should be capable of connecting to those different tools, right? Because you cannot use a proprietary tool that only works with their system, right? We need to find a system that works across these different tools because we can't also restrict the teams to use only the systems that we support, right? That's not the way to scale. So we need to be flexible and say, okay, whatever the system we can integrate. That was one challenge. The other challenge was teams were very reluctant sometimes to adopt these tools because they feel it's overhead, right? So whatever the information that you see here, like teams feel, okay, we might have to spend a lot of time adding this data manually to this system or interact with this system in a daily basis. So if you are successfully deploying a CI platform, everything has to work behind the scene, right? So this data gathering, processing, insight creation, everything has to happen behind the scene, right? So developer should not interact with the SCI platform daily basis because that's kind of adding to its burden because they already interact with the task management system, version control system, some other systems. So we cannot, so they don't like to interact with another system, right? So a good SCI platform should do things behind the scene, right? Without any developer intervention. The third challenge I saw is that they feel sometimes this is used for micromanaging, right? I feel it's a mindset change that we need to have. So you need to focus on um, focus on team level metrics, right? Rather than focusing on individual level metrics, because this tool needs to kind of present data, present insights to you, focusing on the team, not on the individual. So that's another thing, another challenge that we see. Uh, and another challenge would be to sometimes getting teams to use this frequently. I think so. That's kind of one way that we have done is this is now integrated into our delivery excellence flow, excellence delivery mechanism, because otherwise teams need to look at this data and take corrective action. So you need to kind of make these tools part of your delivery process, part of your value process. Otherwise, it's going to be challenging. So these are the main challenges, few challenges that I see, Krishan, in adapting a tool like this.
Okay. It's not easy to get that mindset change that you spoke about. I think that's from the challenges as well. So if I ask you, I mean, having led large teams, how do you get developers to leave their egos behind or their, be able to be more open and see beyond themselves and see the product and the bigger picture?
Yeah, I think it's very important to highlight the value that they get out of engaging in a good product development process, right? And they need to see the value that they get by kind of engaging with the product that they are building and the value that they are adding to the customers. Because I think if you think of yourself as just a coder, right? I think that's not the way to think when you are building products. You need to get to the mindset that you are actually changing the world by helping end users, right? Because otherwise, your product is actually impacting their lives. I think you need to see that in that value. So if you see that in that value, then you shift to a mindset of how can I do this better? How can I kind of build a product that would help my end users better, right? And when you go beyond just a coder, you become part of that product. You become a problem solver, right? So when you are looking at a problem, looking at a product from a problem solver's mindset, then your inner engineer kind of kicks in, because then you can bring in solutions that really works, that really kind of adheres to the right practices, right development methodologies, right design patterns, right architectures, right? And then you as a team should kind of celebrate your achievements as well. So you need to build that value within the team, right? So this is how I think we should look at a product, and this is how you need to motivate people also, not to just say that completing a task, it's not completing a task. You are actually impacting the end user. You're actually impacting how this product is being used by the end user, and that has an impact in their lives. So you're actually changing lives, right? And the technical improvements, the engineering enhancements is also important, because if you're kind of stuck with the same old technology, people get bored, right? So you need to adapt and proactively try to bring in new technologies, right? And see how you can add more value, how you can go up the value chain with your product by utilizing these new technologies, because that will kind of help you to improve as an engineer, and also it will add value to the product as well. So this is kind of the way I feel engineers should think about this and get motivated, Krishan.
Nice. I think that's, yeah, that's really to get them see beyond and see the bigger picture. Right, Suren, thank you for all you've shared, but I'm not going to let you off the hook so easily. We're going to have a
Okay.
few questions just to get your perspectives and views, right? And
All right.
just a few, just 10 questions, and we're going to do this fast. What are the top three developer traits you see as most essential for a power coder?
Oh, wow. Right. Yeah. So curiosity, number one, right? Hunger to figure things out. That's number one for me. Then attention to detail, number two,
Right.
right? Um, Number three is, the mindset to do things right. So getting things like doing things right. So there's a wrong way and right way of doing things. But all the power coders that I have engaged with, they have a keen interest in doing it right the first time. So
Right.
it's kind of connected to the attention to detail thing as well. But
Okay.
they always follow the right methodology. They
Okay.
don't take shortcuts, right? So I feel these three things are the most important if you're a power coder.
Nice. Okay. Good. You have a tech wizard with low collaboration in the team and an averagely productive team player. Who would you choose and why?
Okay, so it's a bit of a contextual question for me, at least. Depends on which project I'm doing. If I'm doing a large project and I need my team to work perfectly, I need teamwork, then average productive team player, averagely productive team player, because being a team player is far more important, right? Because then you can improve with the peer pressure, you will improve continuously your productivity aspect, your competency, and everything. Of course, if it's not a team project, then kind of tech wizardry is also important in that context. Yeah, so depends, I guess.
Good. One lesson you have learned overseeing and managing a team of 40 developers.
Um, oh wow, one lesson. That's tough.
Just one.
Yeah. Mm, I think not taking shortcuts, adhering to a proper engineering and development process. I think that is kind of the best lesson. I think if you take everything together, I think it drill down to that, because every time you take a shortcut or you try to kind of do things in a not in the right way, you end up you hitting a wall, right? So if you sum it up, I guess that's it.
Who's been a tech inspiration in your life and why? As an expert, as a mentor, whatever.
Wow. So you want me to only name one person?
Yes, again, one.
Yeah, again. Okay. Robert C. Martin. So yeah, that's the answer.
Right. So this is a bit of a tough one. If the death penalty was to be introduced for poor development or coding practices, what sort of a what bad practice would constitute such a penalty?
Whoa. All right. Uh, I guess duplicate code and using global variables.
Okay, so better watch out for that one. Top three tools, Suren, in bringing Gen AI to your day-to-day development.
Um, Top three tools. That's a tough one, actually. So yeah, so I frequently use ChatGPT, right? And then Cursor is
Mhm.
my second coding tool, by default coding, right? And Perplexity AI, which is AI based search engine, which I have tried and love
Right.
it. So those are the three things I would say.
Okay. Another tough one. How soon will AI bots or developers or agents replace human developers?
Okay. uh, yeah, so this might be a little controversial. So I'm not going to explain myself, but I don't think developers or I don't think engineers will be replaced,
Right.
right?
Last one. What made you stick around for 15 years at 99X and why?
Oh, well, I guess nobody offered me a job.
That's not the answer.
Yeah,
But
no, I think
seriously,
it's if you ask me one single straightforward answer is it's the culture, right? For me, it was yeah, I loved it from day one, and I still love it. I've never grown tired of the culture, so I love it here. So yeah, that's the main reason.
cool, cool. Before we wrap up, there's one question that has just come in. So we'll take that, Suren, and then we'll close. So in order to make sure that we can hit targets in regards to number of commits and smaller commit size, does the product manage or the team divide up tasks features into smaller pieces, or is that something the developer does? So who kind of owns that change actually taking place?
Usually the story size or the task size is controlled by the product owner or the scrum master. So I think the developers can definitely be part of it through grooming and planning. So if you are planning a larger chunk of a feature, you can definitely say this is too big. We need to chunk it out, and you need to give that feedback to the product owner and the scrum master during that discussion, and then we can kind of break it into smaller chunks. The right size of the chunk, I think that's kind of a tough question to answer because it's contextual, right?
Mm,
What is
mm,
the right size depends on the product that you're building and the context that you're building in, but it should ideally be a vertical. By vertical I mean it should have, if your application is a front ending application, it should have a front end part, the server backend part, and a database part. So you always make sure you deliver some value. The size of the
right,
value is smaller, but you definitely deliver value. You move the value forward always, right? So it's
okay,
kind of in an agile team, I'm talking of course in terms of agile team, I assume it's agile team, right? Which most of the teams are today. So it's kind of the final decision will be with the PO and the Scrum Master. However, the development team should definitely give the input. If the chunk is too big, they need to say this is too big. We need to break it down into value units.
okay, cool. Thank you so much, Suren, for that and also all the other insights you have shared. And to everyone who joined, thanks for being with us. And you can always send your questions to us directly as well. And you can visit www.flowwiser.com flowyer.io to see the platform, FLOWYZER. And again, look forward to seeing you all at our next webinar. Thank you so much, and thanks for joining again.
Thank you so much, everyone.